Okay, class, we're now going to use what we learned with electronic geometries and molecular geometries, or shapes, to now actually draw the three-dimensional shape or geometry of a few of these molecules. Now, we've already done the Lewis structures for these, so I'm just going to take a quick moment and I'm going to generate the Lewis structures very quickly, and then we'll move on from there. So I'm going to go ahead and do that fairly quickly. Remember, these Lewis structures don't care about three-dimensionality. These are just the Lewis structures that we've already done in our earlier work. So I'm just replicating our work. So if you have questions about how we did that, you may want to go back and review that material. Okay, those are the Lewis structures. Now we're going to use these Lewis structures to help us determine the three-dimensional shape of these molecules. So remember that the first thing that we have to do is we have to determine how many electron domains are around the central atom. This oxygen has 1, 2, 3, 4 electron domains around the central atom. 4 electron domains is a tetrahedral geometry of electron domains. So I'm going to go ahead and start to draw that. And now, instead of using capital A for my symbol for the central atom, I'll go ahead and use the symbol for the atom itself that we're using. So I'm going to use oxygen as my central atom. 4 electron domains is tetrahedral electronic geometry. So I'm going to go ahead and draw the electronic geometry here. I have 2 bonded atoms. I'll go ahead and put them on here. It doesn't matter where they go. And these other 2 electron domains are just lone pairs. Notice that this is not a bond to a lone pair. I could just as easily have drawn it as a little balloon orbital. I've drawn it as a straight line, though, to point out that that orbital with that lone pair is in the plane of the paper. Similarly, these dashes show that the orbital with that lone pair is fading away beneath the plane of the paper. So there I go. I have my three-dimensional geometry. I have the wedges here, the dashes there. That orbital with a lone pair is in the plane of the paper. Electronic geometry of this is tetrahedral for 4 electron domains, but the shape, which is another term for the molecular geometry, it's the shape, is bent, just like that. Because remember, to determine the shape, we ignore the lone pairs. So the shape is bent. All right, moving on. We've got our formaldehyde here. There's my Lewis structure. So it looks like I've got 1, 2, 3 electron domains. We know that those arrange themselves in a trigonal planar arrangement. And one of the electron domains is going to be a double bond. So I'm going to go ahead and start to show that. One of my electron domains is a double bond, pointing up here. I've got another one, and I put my bonded atoms on there. And would you look at that? There's no three-dimensionality here because this is a trigonal planar. It's a planar arrangement, planar shape. So there are no wedges or dashes because everything is in the plane. Trigonal planar electron geometry, trigonal planar shape. Okay. Notice I'm not interested in what's going on with the geometry of the terminal atom. just focusing on the central atom for now. Okay, given the Lewis structures that we've already done, I would like for you to go ahead and determine the molecular geometries for these two molecules. Draw them with the correct three-dimensionality, and then name the shape or the molecular geometry of the molecule. I'll pause the video now, and you can go ahead and do that. Okay, coming back from pausing the video, we're going to go ahead and do this. We have a central atom with 1, 2, 3, 4 electron domains. We know that they arrange themselves in a tetrahedral arrangement. 3 of those positions are taken up by bonded atoms, specifically the chlorines, and 1 is a lone pair. Again, this is just showing the directionality of that orbital with a lone pair. Okay? So, we have our three-dimensionality shown. We have a little pyramid here. There's the top of the pyramid with the phosphorus. And the 3 chlorines are the base. And so the shape is a trigonal pyramid. When we are drawing Lewis structures, we absolutely have to have the lone pairs on the terminal atoms. But very often when we are drawing the shape of a molecule, we will omit those lone pairs on the terminal atoms simply because they are not really contributing to the shape of a molecule. But we could put them on if we wanted to. They're absolutely required, though, in the Lewis structure. Finally, we have Xenon Tetrafluoride. I need to fix this Lewis structure because there are a couple of lone pairs in that xenon. So I have 1, 2, 3, 4, 5, 6 electron domains on the xenon. We know that's an octahedral arrangement. So it's a north pole, south pole, and 4 around the equator, 2 going away from us, 2 coming toward us. All right, I have 2 lone pairs. They need to be, generally we would put them on the equator and on opposite sides of the atom, central atom. And our 4 bonded fluorines. And we look at the shape of this, and there's our square. All of these atoms are in a plane, so it is a square planar shape. And there we go. That's how you draw three-dimensional geometries.